We studied this in experimental animals. We are using mice. And the experiments go so that we first infuse the drug in a brain area which is responsible for formation of episodic memories. The drug is called gaboxidol. And once the animals are on gaboxidol, we do a very mild fear conditioning with the animals, which means we put them in an environmental context in a box for 3 minutes and then deliver a mild food shock for 2 seconds.
So you put them in a box, you give them a little electric shock, and that kind of freaks them out.
Exactly. So what happens after that is that if we test the animals the day after, normally the animals show freezing behavior, which shows that they have learned to anticipate danger in that box. They don't feel safe anymore, and they just freeze when we put them back into the box.
But what about the animals that had been given the drug?
The animals which are given the drug do not show any fear response when they're off drug. However, when we put them back on drug, they show fear.
So they're only remembering that they were afraid when they're back in the same state again, when they're back on this drug?
Exactly.
What have you discovered about at the molecular level is going on here?
At the molecular level, we see something which is very, very different from what happens when animals are off drug. So normally, the entire information in the brain is processed using different patterns of activity of neuronal cells, and this entails activation of some cells and inhibition of others. One of the questions that we are pursuing now even more intensely is why we see these individual differences to processing stressful information, why these memories are sometimes accessible and at other times they're not. And we found that for the mechanisms of state-dependent fear mediated by the receptors that we just talked about, the whole group of receptors is regulated by small molecules called microRNAs. And we found one microRNA, which is called miR33, which regulates the level of several GABA receptors. So when this microRNA is high, the receptor levels are low. When the microRNA is low, the receptor levels are high. What changes then, along with the levels of all these regulatory molecules, is the susceptibility to enter in the states where memories are unconsciously stored. So we have this whole family of molecules called microRNA, which are actually determining the predisposition to enter certain states. And we are particularly interested to follow up on the miR33 because it seems that this microRNA is differentially expressed in patients with schizophrenia and major depression. And we believe that some of the states associated with these mental disorders could be linked to the changes of the level of this microRNA.
What does your study reveal about how we make fearful memories?
Well, the study also reveals that there are multiple pathways to stress and fear-inducing memories. And I think that this is very important because patients who suffer from psychiatric illnesses of different kinds exhibit moderate to severe anxiety levels. And at this time, we are treating anxiety with the same approach and the same drugs. We have to take into account, however, that not all fears were created the same, and based on the pathways which are causing these fear responses, we might need to consider to find ways how to identify different approaches for different individuals and establish how to treat individual symptoms. So we have to make better advances towards individualized therapies.